All right. Solving equations. Graphically, numerically, and algebraically. That's a long title. All right, so graphically first. Find all x-intercepts. Okay, so these aren't necessarily going to be all lines. Okay, this is where we are back to like quadratics. So they could be parabolic. Okay, they could be like to the third, fourth, fifth power, whatever. So anyways, find all the x-intercepts. You can use a calculator for these. Okay, we did a little bit with finding intercepts on your calculator last year, I think, but we'll do more with that. So just kind of so you have it in your notes, we would graph the function, okay, on your calculator using the y equals, then use the trace function, okay, which is at the top right of your calculator, to find x-intercepts. Have a zero factor property.
Is that under graphically?
Yes, it kind of fits the numerically / I don't know. It kind of just goes with all of it. Yeah, it's more so just a definition. Let A and B be real numbers. If AB is equal to 0, then A equals 0 or B equals 0. Okay, they could in theory both be 0, but typically it's only going to be one of them. No, I'm not really sure why you're doing the problem. Just reality of the situation. All right, solving quadratic functions. Just a refresher, quadratic functions, can't spell. Can be written in the form ax squared plus bx plus c equal to 0, assuming a, b, and c are real numbers. And in order for it to be quadratic, a cannot be equal to 0. So there's a few different methods that we can use to do this. And one is solving by extracting square roots. 2 is by completing the square. Okay, so remember with that, I'm going to just throw this in really quick. Okay, we'll do examples, so I know it's going to be fast, but I'm just kind of in a time crunch here. Okay, you would normally put the box in here, okay, and then it's half the middle term squared. is equal to whatever you do to one side, you've got to do to the other. So I've also got to have that box over here with that b over 2 squared in that. So if I were then to factor it to help me solve it, which is obviously what the benefit of completing the square is, I'd have x plus b over 2 squared is equal to c plus b squared over 4. Okay, again, it probably makes less sense with letters than it does when we actually throw numbers in it. So when we do the examples, it'll make more sense. Method 3 is factoring, which hopefully by this point we can all do pretty well.
It's just the b squared and not the 4 on the number.
On over here.
Yeah.
So it was 2 on the bottom, so I went ahead and squared that. So the squared is now just on the b on the right side over there. And then the last method is using the quadratic formula. It's pretty much the one you can guarantee the most will work.
Yeah.
Yes, but it's not always the most beneficial because obviously that requires a lot of work. But you could probably factor some stuff easier, but it's the foolproof method to use the quadratic formula.
Which one would be the fastest way to do it, you think?
Well, it really depends. I mean, a lot of times factoring will be, but there are problems factoring will not work for.
And then you would use the quadratic.
If it's not factorable, you have to use the quadratic formula. So the quadratic formula, okay.
I remember that on the worksheet because there was like some factoring problems, and I was like, you can't factor this. And I was like, oh, we need to put in a quadratic formula.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, as long as it's back there on the back wall, it's fair game. If I take it down, I might let y'all write it and on your quiz, test, whatever, and give you an extra point for it. But most of the time, I just leave the poster because there's no point taking it down. It's back there, currently behind Taylor's head. It's fair game. Don't stare at Taylor for like a whole quiz or test or something. That's awkward, but it's back there if you need to refresh and make sure. Okay, if I leave the poster up, there's absolutely no reason to get the formula wrong. So.